Hello everyone, welcome back to the class real-time system. Previous classes we have talked about introductions and the basic things of real-time systems, historical background, real-time system definitions and classifications of the real-time systems. Okay, so those things we discussed in the previous video. So now we are going to discuss about the time constraints. Okay, so the time constraints based on the real-time systems. Okay, so the real-time systems are divided into two categories. One is the hard real-time system and also a soft real-time system. First we'll see what is a hard real-time system and soft real-time system, then we'll go for the example. Okay, so the hard real-time system, it is nothing but these are the system that must satisfy the deadline on each and every occasions. Okay, it must satisfy the deadline on each and every occasions. But in soft real-time system, these are the system for which an occasional failure to meet the deadline does not compromise the correctness of the system. Okay, hard real-time system, if it is meets the deadline, if it is crosses the deadline, there is a huge failure may occur, huge damage may occur. That kind of systems are hard real-time systems. And soft real-time system, if it is a failure occur, that kind of systems are acceptable. For example, the hard real-time system examples are the air traffic control. So in that, if it is crosses the deadline, there is a huge damage may occur. Okay, but in soft real-time system example, I can go with the reservation systems. If it is crosses the deadline, there is no problem with the failure. Okay, so either the seat may confirm or it may not be confirmed. Okay, so there is no huge damage in the soft real-time system. That kind of failures sometimes can be acceptable, so it is called the soft real-time system. Okay, so that is typical examples of this hard real-time control system is a temperature control loop of the hot air blower system. Okay, so the designing of the suitable control algorithm for the system, which involves the choices of the sampling interval in time seconds in TS. Example, the 10 milliseconds of time which is given. So then at the 10 millisecond interval, the input value must be read and control the calculations carried out, and the output value must be calculated and sent to the heater drive. Okay, so it is a temperature controlling loop for the hot air blower. So the time limits which is given, the deadline which is given is 10 milliseconds of time. So within the 10 milliseconds of time, the input must be read and calculate the controlling information, and that output value must be calculated and that must be sent to the header. Header in this nothing but it does not be to a destination, that is heater drive. Okay, so that is nothing but on the hard real-time system. Okay, so the examples of the hard time constraints associated with the event-based task. Okay, it may be an event-based task. Assume that the hot air blower which is used to dry the components, if exposed to the temperature which is greater than the 50 degrees Celsius for more than 10 seconds of time, then there is a possibility of damage. So it is nothing but an event based system. Okay, so the component, whenever the component which comes for the dry, okay, so that time we need to control the operations which should not be exceed the limit which is given. So the 50 degrees Celsius for 10 seconds of time. Okay, if it is exceed, there is a failure may occur. Okay, and the soft real-time system example, we can go with the ATM. ATM is the examples of the soft real-time constraints. Okay, if it is exceeds the deadline, there is no problem. Either you will get money or we can claim it later. Okay, so this is there is no huge damage in the soft real-time system, but there is a huge damage in hard real-time system, that is called the hard real-time systems, and the failure may be acceptable. That kind of systems are soft real-time system. Okay, and when I come to this equation part, okay, the constraints can be defined as it is a hard real-time system and it is a soft real-time system. So the hard real-time system, it's nothing but what? Each and every occasion that must meet the deadline. So when the hard real-time system, when it is on periodic, when it is on aperiodic, that means it is on cycle wise. I mean with a keep on doing with a predefined value, the time interval, the fixed time interval, and whenever the event is occurred, that is called aperiodic. Already we have discussed in the classifications of real-time system. Now the hard real-time system which performs in periodic manner, the hard real-time system which performs in aperiodic manner. Okay, so in the periodic manner, Tc of I is equal to Ts plus or minus A. So what is the Tc of I? It is nothing but the interval between the I and I minus 1 cycle. Okay, interval between the I and I minus previous cycle. Okay, so that is equal to Ts. What is the Ts? It is nothing but the desired periodic interval. Okay, and plus or minus A. A is nothing but a small timing tolerance which is given. So this must be performed. The time interval must be within the difference between this cycle to the next cycle, it will be calculated. Okay, so within this time limit it must be completed. Okay, and aperiodic event, so it is given Te of I. So what is the Te of I? Te of I is nothing but the response time to the ith occurrence of the event. Ith occurrence of the event is nothing but whenever the event which is indicated or initiated. Okay, so the Te is nothing but the maximum permitted response time to the event E. So here there is no time limit, it isn't depending on the maximum time limit which is given. Okay, so it is called the hard real-time system. And when we come to the soft real-time system, it is also performs based on the periodic cycle and also a aperiodic cycle. So how which performs in the soft real-time, I mean periodic and also a aperiodic event. Okay, so when we come to this periodic cycle, it is nothing but 1 divided by n. Summation of I is equal to 1 to n, Tc of I is equal to Ts plus or minus A. So these equations and all equal, but it is the n is nothing but the number of occurrence of the event E within a time interval T, or the number of cyclic repetition during the time interval D. Okay, time interval T. So that is represented by n. Okay, so the summation of the number of times. So like this, how this will be calculated, where n is nothing but capital T divided by small ts. What is a capital T? Capital T is nothing but on the time. Okay, it is a maximum permitted response time divided by the ts. It's a desired period cyclic interval. Okay, so and aperiodic event. So it is also similar to the hard real-time system, but here we are calculating the cumulative amount. 1 divided by n, summation of I is equal to 1 to n, Te of I is less than or is equal to Ta. So where n is nothing but capital T divided by small s, the same thing. Okay, so these are the informations which is given, the constraint how it will be calculated. And when we come to this classifications of program, the program classifications. So the first of all, the subdividing the real-time task into the two different types, which arises from the different levels of difficulty of designing and implementing the different types of computer program. Okay, so the experimental studies have that shown clearly that certain types of program, particularly those involving the real-time and interface operations, and substantially more difficult to construct them, for instance standard data processing programs. Okay, so the mathematical techniques for the proving the correctness of the program and the development of the formal specification languages such as Z and also here the VDM has that clarified the understanding of the difference between the different types of programs. Okay, so now that program, there are three types of the programming, that is sequential programming, multitasking programming and real-time programming. Okay, so the definitions which is based on the kind of argument which has to be made in order to verify, that is to develop the formal proof and also the correctness of the program for each type. Now we will see what is a sequential type, sequential programming. So that actions are strictly ordered as a time sequence. So the behavior of the program, which is depends only on the effects of the individual actions and their order, and the time taken to perform the action is not of consequence. Okay, and the verification and requires two kinds of arguments. One, that is a particular statement defines the stated action, and second one, that the various program structure produces the stated sequence of events. Okay, so the sequential is nothing but the actions are strictly ordered in the time sequence. So the behavior of the program, which is depends only on the effects of the individual actions and their order. Okay, so it will follow the order one by one, it will execute, and the time taken to perform the action, it is not a consequence. Okay, and the verification requires the two kinds of argument. What are the kinds of arguments here? The particular statement definitions a stated action, and the various program structure produces the stated sequence of events. Okay, so this is all about your sequential. And the next one is the multitasking. So the multitasking, you know that it multiple actions which takes place. Multiple actions which takes place. Multiple tasking is nothing but the multiple program which executes at the same time. Okay, and so in multitasking, we know that the multiple operations must execute or takes place in parallel manner. Okay, so the action is required to perform or not necessarily disjoint in time. It may be necessary for the several action to be performed in parallel. Okay, so whatever the actions which is performing, that should perform in parallel. Such a program may be built from the parts, that is the processor, or it may be from the task, which are themselves the partly sequential, but which are executed concurrently and which communication through the shared variable and synchronization signal. Okay, so the whatever the sequential operations, the one can be performed at a time, but there is a sequential operation, the communication between the one task to another task which takes place. I mean the shared variable which is communicate between the other parts. Okay, so there is a synchronization between the other tasks. So here the verification, which requires the applications of arguments of sequential programs, and additionally, okay, so the verification requires the applications of arguments of the sequential program, whatever we have discussed earlier. Additional to this, the task can be verified separately only if the variable of the each task are the different, the process are different. Okay, if the variables are shared, the potential concurrency makes the effects of the program unpredictable unless there are further rules that govern the sequence of the task. Okay, so if it isn't from the different task, the different processor, then that must be verified separately. And if it is on shared variable, the concurrency between the concurrency which makes the effects of the program is unpredictable unless there are the further rules that govern the sequence of the task. So use of synchronizing procedure means that each task can finish at its own speed. Okay, so this is all about your multitasking of the real-time systems, I mean the program. And when we come to this real time, so in addition to this, to its action, not necessarily by being disjointing in time. Okay, disjointing in time, the sequence of some of the actions is not determined by the designer, but by the environment. External events occurs in the real time and not depending on the internal operations of the computer. Okay, so the real-time system, it is nothing but what? It operates in the real-time program. Okay, so it is not necessary being the disjoint in time. Okay, it may be executed in a continuous manner. Okay, some actions is not determined by the designer, but it may be determined by the environment, that means by the external event. So the occurs in the real time and not depending on the internal operations of the computer. Okay, so the real-time programs can still be divided into the number of tasks, but the communication between the tasks cannot wait for the synchronization signal. So the environment task cannot be delayed because it is on real-time operation. So the time delay must be very less. Okay, synchronization must be there in between that, but it should not be wait for the synchronization signal. So whatever the operations which performs, it should be transmit in a frequent or continuous or predefined manner. So actual time taken by the action is an essential factor in the process of verification. Okay, so the type of reasoning necessary for the verifications of programs is very much important as an engineer or seeking a method of the formal proof, but because as we are seeking to understand the factors which need to be considered when designing real-time software. Okay, so and so before going to the summary, actually I want to tell you about the softwares of the real-time applications. Okay, so the designing of that real-time software is significantly more difficult than the designing of the sequential software. Okay, so in order to overcome the problem of the real-time software design, the specialized programmer produces an operating system used to be a general purpose, so that they can be used in a wide range of applications in order to reduce the unit cost of producing them. Okay, so these operating system could be tailored that this they could reassemble and execute or include in a certain future. Okay, so and that's all about this topic. So the first unit is over in this up to this. Okay, so in this we have talked about in this first unit we have talked about introductions and also the histories of the real time and the definitions of real time and classifications of real time and the time constraints and the programming classifications. So these are all the things which we discussed in this unit. Okay, so when we come to the summary, the computer control which involves many different activities that have to be carried out concurrently. Okay, and the digital computer or the sequential devices that are an individual computer that can give because of its speed of operation and the appearance of carrying out the activities concurrently. So and the real-time systems have to carry out both the periodic and also aperiodic activities, and the real-time system have to satisfy the time constraint that can be either a hard constraints or it may be on the soft constraints. Okay, so the real-time software is more difficult to specify, design and construct than the non-real-time software. Yes, obviously the real-time software, it's very difficult. We have to check many times before going to implement, because it is operates in the real time. It's based on the environment or based on the event occurrence. Based on that, with the real time system which performs. So when we are designing a real time system, we need to design very carefully and check multiple times before going to implement, or otherwise there is a possibility of the system may failure, or there is a possibility of degradation may occur, or the huge damage can occur. So this is all about here the real-time system basics. And the next unit what we are going to discuss is the controlling, loop control. Okay, so the different types of loop control we are going to discuss in the next videos. Okay, and these are the textbooks. And when we come to the video question papers, this topic is very much important. You may see in your main examination this kind of questions. Say I will tell you, define the term time constraints and how the RTS are classified based on the time constraint. Explain them in appropriate equation. So for this you have to write what do you mean by the time constraint. So the time constraint which is classified based on the hard real-time system and also a soft real-time system. In the hard real-time system, periodic and also aperiodic systems are there. Similarly, the soft real-time system, periodic and aperiodic systems are there. That the equations are defined. So that equations you have to define and explain. Okay, so this is one of the important question. And computer control system, it is also one of the important one, not that much important, but it's also there in your previous year questions. And the programming, when I come to this program, explain the following type of programs: multitasking and also a real-time system. So it is asked for 6-mark question. And the differentiation between the clock based and also event based task, it is 4-mark question. Okay, so those questions are very much important. So, and the clock based system, again the clock based system, event based system, again it is asked for 4-mark question. And explain the different types of programming in system design, it is on 6-mark question again. And what is a real-time system, explain the general computer control system with a need block diagram, it is 6-mark question. Okay, so the whatever we have discussed, it's all the questions are important. You may get in your main examination, I mean either it may be for 4-mark or it may be 6-mark. Okay, I hope this topic is very useful for you. We'll meet you in the next video. Thank you all.